Hi guys, welcome to another Learning Electronics Repair video. I have here some MAG 250 IPTV boxes. Some of them are complete. This one I'm sure I've got the top off of it somewhere, a couple of PCBs. And I was hoping I could fix some of these. So what I'm going to do first is just test them all and see what they do, and I'll stick stickers on them so we know which ones are which. And then I'll come back when I have a list of the faults, and then let's see what we can do with them. Okay guys, so there were 6 and now there are 4 because 2 of them were working. I powered them up off my bench power supply, and I can see that the 2 working ones actually draw about 550 milliamps, just over half an amp, 0.55 amps if you like. Those are working. Out of the other 4 then, one of them, number 2, is actually drawing 3.6 amps. This appears to have a short somewhere. Yeah. This one, number 3, is only drawing 20 milliamps. But I've noticed just looking at this has an inductor coil missing. Something's been taken off this, so this is being salvaged for parts at some time, because you see this has 2 coils here, this has 2 slightly different ones, and this has 1 missing. Yeah. So that's got a part missing. So we'll put that on one side for now, and the idea being, if we can't fix one of the others, we can use the part. If we fix all the others, well, we'll have to get a part. Yeah. So that's that one on one side. This one then, number 1 and number 6. Yeah, these are both dead, in as much as they don't light up. The light doesn't come on. But they both draw a similar current. One's drawing 270 milliamps, the other one 210 milliamps. So they're obviously drawing less than they should do. So I think what we'll do with these first is let's take one of the good ones, open it up, and let's measure the voltage on the coils. I'm just looking at these now so I can see 2 buck regulators here. These are probably the controllers. I can see this looks like a linear dropout, an LDO regulator there, same on this one. And then this chip here might be an LDO as well. I'd have to look up the part number just to see. Oh, I'm thinking of it. Yeah, looking here, there's this little chip. I'll zoom down in a minute. There's a little 5-pin chip here. In fact, let's just zoom down so you can see them. That's better, guys. You can see now. So we can see on here we have 2 buck regulators. Yeah. 2, and on the one I mentioned that one of the coils is missing. Okay, so 2 buck regulators, there'll be 2 voltage rails. We have a little 5-pin device here which may well be a linear voltage regulator. We have this chip here which I just need to get the part number and see what that is. Could be a voltage regulator. There's lots of capacitors around it. And we have on the back another 5-pin device here which may also be a regulator. So that's what I can see looking around the boards. So as I mentioned, if we take a good one, and we'll just check what this is first. Now let's take a good one and let's have a look at the voltages on a good one, and then we can start comparing with the bad ones. I've checked the data sheet for this device, this one, R4580i. It's a dual operational amplifier, so it's not actually a voltage regulator. Just having a closer look at these, I think you can see that this is the negative of the main capacitor, and this looks like a ground that's going up the middle of here. Yeah, it looks like we've got input or output capacitors here going to this pin and this pin by the looks of it, and it looks like if this isn't ground, this is an output. Or this one, there's another capacitor here, but I'm pretty sure this is a voltage regulator. The same applies to the one on the back of the board, and I think it's a little bit clearer on this one, as we can see. Let's just get the focus on this one. So this fairly obviously has some heavy traps coming in here. One I'm sure will be a ground, yeah. This looks like it could well be an input capacitor, and then this side is another voltage rail. So this is likely in and out, or in and out, one way the other around, and a ground. So I'm pretty confident that is actually a voltage regulator. You can see the part number, VCAQ, and the one on the other side is something different. It's a Let's just zoom down and have a look what it is. It's a ADSH, okay, or ADSM, ADSH by the way, sorry. Okay, so let's get one of the good ones and let's measure some voltages on that, and then let's have a look at these ones. This then is a working one, so we'll just connect the power and let's have a look. So we have some power on it. So this little voltage regulator, so I'm pretty sure it's a voltage regulator, this thing here, let's have a look what we've got. So coming on here we have 3.3 volts here. Yeah, there's a 5 volts coming in, so this is a 3.3 volt regulator. We can say for sure, I mean the 5 volts is going to be coming in on one of the pins, but that is definitely a 3.3. There's a 5 volt coming in here on this capacitor, and that appears to be, that's 3.3. You know, I don't even need to bother trying because I know it's here somewhere. Oh, there's another one over here. What's this thing? What's this thing doing? Let's have a look. I'll just get to look down the microscope so I can get a good contact on it. What's this? Well, that appears to have 15 volts on it. Some of the pins on here. That's strange because is that volts? 4.4. Do we really have 15 volts on here? We certainly do have 15 volts on there. One end must be input somewhere else on here. That's a ground. What's on the other one? That appears to be a ground. What's in the middle one? They all appear to be 0. Interesting, they seem to have 4.4 volts coming in. What's on here? 4.4. Oh, it looks like my 5 volts coming in by the time it's come down the wire is 4.4, but it seems quite happy. So 5 volts coming in and 15 volts coming out of that one. This one is a 3.3 volt regulator. Then we have the 2 buck regulator cores. So what's on these? I'm guessing one's for the RAM and one's for the core. That's 3.3. This one. 1.2. Okay, I'll just make a note of some of these on a little diagram. One moment, I'll just make a note of these. Okay, just made a note of those. Because this buck regulator is 3.3 volts. In fact, it actually says 3.3 volts next to it now. I can see some markings on here. Because that's a 3.3, I'm wondering now if this one up here has 3.3 volts coming in and the output is actually something else. So let's have a look around this one. So have a look on here. Ah, that's 0.627. That's 0.6 of a volt. It's on the middle one. Ground. It's on these two. 0.9 of a volt. And this one. There's the 3.3 coming in. This looks like it's a 0.9 volt regulator. Yeah, it looks like it's a 0.9 volt regulator. So I'll just make a note of that one. 0.9 volts. Then there's 2 more. So we have this one here. It actually says 1.8 volts and the part number is LD18, which makes me think low dropout regulator at 1.8 volts. So this should have 1.8 somewhere. Yeah. Okay. So that thing is actually a 1.8 volt regulator. I'll just draw it anyway. 1.8 volts, and then there's one on the other side of the board, which was this one here. This one, just a focus slightly. There we go. What have we got here? It looks like we've got some sort of voltage supply coming in here. That's the 5 volts, which isn't quite 5 volts. And what's on here? I'll just get down the market so I can actually see it. 0.7 of a volt. What's on this one? That appears to be ground. So what's on this one? Just get into the microscope again. It goes to this resistor here. 3.3 there. So this looks like if anything's coming out this way of a voltage, it's quite a low one here. In fact, now I don't have it. 4.6, where was I? Had it somewhere. Slipped off that one. No. Is this middle pin? Nothing. I could have sworn it was here. Oh yeah, there it is. 4.6. No. So I can't see anything obvious around this one that actually would tell me if anything 3.2. Okay, we can have a look at the one on the other one. I can't see any obvious answer as to what that actually is, but we can have a look at the other one. I mean, maybe this is some sort of logic device and it's not a power supply at all. Okay, let's have a look at some of these bad ones now and compare them with this one. This is number 1 then. This one and number 6 had a very similar problem where the light doesn't light up and they draw like 200 odd milliamps. So let's have a look at these two because they're quite similar to each other. So we'll power this one up. Yeah, it's drawing 230 milliamps. Let's have a look. So this is the 3.3 volt supply and it's running. This is the 1.2 volt supply and it's running. This is the 1.8 volts and it's running. So they're all running. And then there's this one up here which is like a 0.9 of a volt. And on this one it should be like 0.123. This should be the 3 volts coming in. So it's like the other one. This, by the way, appears to be different from the one I just tried because there's only one chip here. Yeah, the other one had two chips up here, so they don't seem to be the same. But this doesn't appear to be working, this thing around here, yeah. It doesn't seem to be the same as the other one. There's a 3.3 coming in, which the other one had 3.3 coming in. But this only has 0.12 going out, not the 0.9. Okay, so let's have a look at that one. Now let's have a look at the other one. So that's that one. Number 6. So this is a very similar problem on this. What's this one doing? This has a different power connector. These, by the way, the small power connectors are copies or clones. The other ones have like a larger power connector on the original ones. Okay, so that's plugged in. The lead's a little bit shorter, that's all. I have to move it a little bit. Let's see what this is doing. So this is the 3.3 and that has 3.3. This is the 1.2 and it has 1.2. This is the 1.8 and it has 1.8. This is this little chip here. It's 3.3 coming in, and what's coming out of this one? 0.33. They are definitely different from the other one. I'll have a look at the one with the short a bit later. I'm going to take the other good one and see if it's actually the same as these two, so I can actually make a proper comparison. But it looks like there's something wrong with this regulator on both of them. Interestingly, this one seems to be a slightly different design. Again, although these are all the same model, this has a different chip here, and it has a 6-pin device here, so a different chip here as well. So we unfortunately can't get an exactly close comparison with them. I can have a quick look just to see what voltages are up around here. Let's see if I can find the 0.9 volts which we had on the first one. If we do find the 0.9, at least we know pretty much what's wrong with the other two. So just power this one up. It powers up. Let's get the ground lead onto it. There we go. Now let's see what we got here. So I'll just the focus slightly. Now let's get a look down the microscope. Let's have see what we have on this one. So somewhere up here is where we'd expect to find this 0.9. Well, there's nothing on that pin. Nothing on that pin. Nothing on that pin. Oh, hang on, this thing's gone off. That's interesting. There's got a bad connection on it. Yeah, it's on again now. I had a bad connection on the power. Let's have a go. So, nothing on that pin. .34. Nothing. Nothing. It's still on. 0.7. This middle one, 3 volts coming in. Okay, I can't get any inclusive, sort of conclusive evidence from these working ones. They all seem to have different voltages around this chip, and I'm not quite sure how relevant that is. So let's have a look at number 2. This is like the other 2 that we have, but this one is drawing a lot of current. This appears to have a short circuit somewhere. So maybe if I can actually find the short circuit on this one, then I can actually see what voltage is around this chip and then make some comparisons with the other 2. I decided to check if there's any short circuits on number 2, the one that draws a lot of power, on the various buck regulators and voltage regulators. And from that I then decided just to measure the resistance on each of the voltage rails, on all of them. So on a good one, on this is where I'm seeing the 0.9 volts. I tried again, I'm seeing 0.75 of volt there. It seems to change. But on the 2 pins on this side of the regulator, I've got 1.16k and 140 ohms. That's on a good one. Now, on the bad ones, none of them read 1.16 on this pin. I've got 3.2 meg open circuit and 28k. So they're all reading completely different there. And they're also reading different here. So this was a good one. And on the bad ones, number 1 is reading 1 ohm, but that isn't the one that has the short, it's number 2, yeah? So number 1 reads 1 ohm on this pin. This reads 10k, and this is completely open circuit, and the good one reads 140. So there's a big discrepancy there around this little regulator chip, and we need to have a look now to see if we can find a data sheet for this and figure out what pin is what. The 3.3 volts, I've got 24k on the good one. I've got numbers 1 and 6 reading 28k. So that's the 2 dead ones that are not drawing too much current. And then number 2 is reading 10k, considerably lower on the 3.3. On the 1.2, I'm assuming this is going to the actual BGA core, the 1.2 volts. So again, it's very strange. I've got 550 ohms on a good one, and then they're all over the place on all the other ones, completely different. None of them are short. And the last applies on the 1.8 volts. I've got 260 on the good one. That one was close on number 2, and the other 2 were well different. So it seems to be a lot of variation, and it's a bit difficult exactly to know what is what with them, but certainly around this chip I'm seeing a big difference. Number 2 has a short circuit on one of the pins, yeah? Sorry, number 1, sorry, has a short circuit on one pin of this chip, and the other 2 are reading, well, that's a good one, and those have pretty much open circuit on the same pin. So that's a good place to look. And the other one is why number 2 is drawing a lot of current when I can't find any shorts. So I'm going to power number 2 up, and we'll have a look at what current it's drawing and see if we can actually figure out, I mean, something at this current should be getting hot. So we'll just take the camera so you can see the, move all the wires out of the way, you can see the bench power supply there. I'll just make sure I have the right power connector plugged in, which I do. Okay. So you'll see yourself when I power this up. Look, it's drawing a huge current. And yet, if I go onto the input, I don't see any short. You know, it's just good to hear. on the actual, on the 5 volts coming in. Do I see a short? I don't think I do. Oh, sorry, you want to see the meter, don't you? I tell you what, let's put this there as well. You can see them both. Yeah, with a bit of look. There you go. Yeah, you've kind of got a view of everything now. Yeah, there you are. Okay, so on the voltage supply coming in, I'm just going to that now to ground. I don't see a short. Yeah, you go the right way around as well, right polarity. But I don't see a short. Yeah, there's no short there. So why is this drawing so much power? You know, why is this drawing like over 3.5 amps? Where's that current going to? Let's have a look, see if we can figure it out. Let's put this onto voltage. Do I have any voltage getting this far here? Yeah, like 3 volts, so the other is being dropped down the wire. Ah, something's getting hot on this one. Ah, right, the core is getting very hot on that one. Okay, so we know this has got this core is getting very hot. The whole area, all this is getting very hot. Everything's getting very hot. Yeah, so I'll put it back on again. Just check the voltages. Yeah, we're on volts. You should see that all these voltage rows are probably low. Yeah, there's 2.8 on the 3.2. 2.2 on the 1.2. So this looks to me like, yeah, this is getting hot. This looks to me like we've got this voltage rail, which should be 1.2, generating too much voltage, and it's all going to the core, and this is getting really hot. Whether by fixing that and getting it down to 1.2, if this is survived, is another matter. But that's what's wrong here. Yeah, there's too much voltage on this voltage rail. It's reading 2.2 when it should be reading like 1.2, and this is why the thing, so go again because we've done it several times now. Yeah, this is why this is getting very hot. 2.2 volts. Yeah, this chip's getting hot, and this is getting hot. Yeah, that's why this is drawing a lot of current but not showing any short circuit. So we know what's wrong with number 2. Yeah. And we could possibly try to fix it. Right, maybe we'll have to check the pin out for this regulator and see what it is. Yeah. So let's have a look at number 1 and 6 again. So now these have very different readings around this regulator here. All the rest of the voltages seem to be okay. And if I just plug this one in, you can see it's drawing 220 milliamps. Yeah, it has the correct voltage. We've checked it before. 1.2, yeah, and this is cool. Yeah, nothing getting warm because it's not drawing much power. Okay, so let's get the pin out for this device. Let's see what it actually is, and now let's see if we can work out what the problem is with these two. Yeah, where we're going wrong with these two. So there's our little chip. This one's actually marked slightly different from the other ones. It's actually marked, I think it's F1HD. Let's just get some focus and let's just get a torch and let's have a look to see what that says. Let's see. It says it wants focusing a little bit. So that one's F1HD. Okay, that's on number 1. So number 6, this is the one that says ADSH. Yeah, I suspect they're compatible chips with each other. ADSH on that one, and this is number 2, the one with the high voltage into the core. ADSH. Okay, let me see if I can find the data sheets for these devices, and then let's see what we can work out from that. I had a good look around on the internet, but I wasn't able to figure out what the SMD code of these devices actually refers to, the part number. So I've actually posted up on Badcaps forum, badcaps.net, and see if anybody on there knows what are knowledgeable guys there. Hopefully somebody will know what they are. I've also come to realise they're not exactly the same. This is the one marked F1HD, and this is the one I was reading a short circuit on pin 1. So this is actually board number 1, yeah, and I was reading a short circuit here, but when I look at it, in actual fact, just get back into the shot, on this one, pins 1 and 2 are actually connected together on the PCB trace, yeah. So this is the 3.3 volts on here, pin 1 and 2 are together, and this is some sort of output as far as I can see with about 0.7 or 0.9. Look at the other ones, just getting to the same place. You'll see that if I can zoom it in and focus it, there we go, all the way. So you'll see on these ones with the ADSH that pins 1 and 2 are not connected together. Yeah, pin 2 is still ground, but pin 1 isn't. So there's some difference. Another thing I sort of noticed, so number 2, which is the one with the short somewhere, well, we know it's too much voltage on the core, it's getting hot, yeah. I was looking at the devices here that actually drive the 2 buck regulators. So we have this one marked 1597A, and we have the other one marked the same 1597A. But if we look at some of the other boards, they're not the same. Again, they're different. So this one is number 1. Let's find where the book. There's the buck regulator coils. And look, this has two chips up here, different chips, yeah, driving these. So they're different. They're different. This is the other one, and this has 2 little chips here. One there, well, one here probably. But again, oh no, sorry, 2. One there and one there. Yeah, again, they're different. So the only 2 I have that actually are the same appear to be number 3 with the short on. I'll just go over to the camera. So number 3, which is the one that has, well, not a short, but the too high a voltage into the core. Yeah. So sorry, number 2, which has too much voltage into the core. And number 3, which is the one that has a missing inductor. The 2 that appear to be actually the same. And I was just checking the revision numbers down here, and these are identical. So while I'm waiting for the information on what those other chips are, so I can see why there's so much difference between all the boards, let's have a look at this. So we know there's too much voltage on this supply, and this has the same driver chips as this one. So what I'm going to do now is take this coil off here and fit it onto here and see what this one does. Okay, if this one produces the right voltages but isn't working for some other reason, I may well try and find a data sheet for this, and I may end up taking control off one onto the other one, and then seeing, although I doubt it, if we get the voltage correct on this, it actually survived and works. But anyway, to start off, let's just remove this inductor and stick it over onto here. Okay, so we now have the inductor on number 3. Let's see what this does. So you can see the power supply and you can see the meter. What current's this one going to draw when we plug it in? This has got a short on it again, yeah. This has a short somewhere. I just have the same problem as the other one. We've got too much voltage on this core. Let's have a look. So we'll power it up. We've got the voltage meter on. Power up. Too much voltage. Core's getting warm. Let's see if there's too much voltage. No, this doesn't have a too much voltage there, so something else is problem with this. Oh, something smells like it's burning on this. This has a short somewhere. See if we can find it. So 1 ohms range. We've got a short on the input. No, we've got a short on any of the rails. Well, that's reading 10 ohms, which is much lower than the other one was reading. 390 ohms. This is a 3.3 volts, and it's only reading 10 ohms on this, where the other ones were reading, oh, high 24k. So this has got some problem on the 3.3 volt. Let's have a look. 10. Where's that go to? 11. I think I need to figure out what's actually getting hot on this. There was definitely something was getting seriously quite warm. Okay, let's try it again. It might help if I put a bit of isopropyl alcohol on and try and figure out what's actually warming up on this. Let's see if we can do it. Got some a bit of isopropyl, a little paintbrush. Let's just put it around and see if we can figure out what's actually getting warm on this. Yeah. I'll take it off my bit of paper so it doesn't smear everything, of course. Okay. Let's see if we can figure out what's warming up first. So I'll just put it all over the board. Okay, there we go. Now let's power this up and let's see if we can figure out where the heat's coming from. Okay. Oh, yeah, it's the CPU. Right. So straight away we can see this is what the problem is with this one. Yeah. What voltage is on this thing? I'll see if we get it again. I'll just attach a ground lead onto the meter to make life a bit easier. Yeah. Okay, there we go. So we know. In fact, what was happening is this regulator was getting warm as well, because that's obviously supplying the power. Yeah. So we can get onto the actual coil. Now I'm on it because I'm reading the resistance. Let's go to voltage and let's plug it in and let's see what happens. I'll just put the meter so you can see it. There you go. Let's have a look. Okay, ready? Here we go. Well, there's basically no voltage there. Yeah. In fact, it looks like the 3.3 as well. Yeah, the 3.3 must go to that as well. Okay, so this has got a problem with the core. We know that. I think what I'll do with this one then, I'm going to take this BGA off the board, and then let's see if we've actually got the correct voltages. And if we have got the correct voltages, let's see if we can get the correct voltage onto the other one, number 2. Yeah. Okay, so let's get this chip off here. I'm just wondering whether to do it with the BGA machine. Yeah, I'll stick it on the BGA machine. Let's get this off here. Hey guys, so the board's on the BGA machine. I've selected this profile, which is a general one I use for BGA chips. Hopefully this will actually do the job. So the top and bottom nozzle go up to 253 on the final step of this one. So we can use this curve. I'll just make sure I actually have the set as the current curve. Yeah, lead-free stubborn I call this one. So that's okay. So I've now set it to remove. So we'll choose run, and then we can actually start this profile. This is a previous profile I've been running on the machine the last time I was using it. So that should just go. I've just put the little temperature sensor onto the board. So the turquoise colour is the actual sensor. It's a little bit far away. Let me just get a little bit closer. So I've actually put the sensor, you can see it there by the corner of the BGA. So let's let this run now, and then let's see if it actually removes the chip. Okay guys, you can see that came off quite nicely. So there's the PCB. This is the actual the chip. And I mean, obviously I haven't cleaned it up, I've just wiped the flux off it. But there we have it. So nice clean job. I mean, if I was ever wanting to replace a chip on there, I could do. I'd have to find either find a template to if I need to reboard a chip. But anyway, there you go. There you go. So let's have a look. So this is the 3.3 volts that had the low resistance on it, and it's now reading 278 ohms, which is still actually lower than I was reading on some of the good ones. But 278 ohms on there, and this is the other voltage supply, the 1.2. And that's reading about, well, 1.8 meg. That's very high. So let's power this board up now, and let's see if we have the correct voltage on here, if we actually have 1.2 volts. So we'll just set this over there. I mean, you'd expect this to draw very little power now, so let's have a look and see what we've actually got. Yeah, so it's drawing just 200 milliamps now. And we can have a look to see what voltage we now have on this regulator. Okay, and that's 1.2 volt. And 3.3 now, I'm sure that it was actually now reading 5 volts. It's gone high, possibly because there's no load on it. But this is reading 1.2, and that's what we were interested in. So this controller chip is actually working. What we'll do now is let's have a look to see if we can find a data sheet for this, to see if there's any other reason why the one will be giving too much voltage. And if we can't see, then let's take this chip and put it onto the other board, and let's see if by any remote chance is the actual process has actually survived the 2.2 volts on it. I found a data sheet for this, so let's have a quick look at it. So this is the thing, NCP1597A, and you can see there's 6 pins on it in the ground pad. Now, if we look at the pins, the main one I'm interested in at the moment is pin 1, which is the feedback pin, and it's saying connect a resistor divider from the converter's output, that's the output of the buck regulator, to this pin. Yeah, so we have a resistor divider which goes from the output, and the other end of it goes to ground, and it monitors on this FB pin, feedback pin. So if we look at our board now, we can actually see how that is. I'll just go to the microscope there, right. So this is the chip 1597A, and you can see there's a dot here, and this is pin 1, this is the feedback pin. Okay, and you can clearly see it goes to 3 resistors. It actually goes to this point here, which is the junction of these 2 resistors, and from the end of here, if I go to ground, if you see on the meter, that's ground. Okay, and the other end of this is actually, I'm just onto the buck regulator coil. That's the buck regulator coil. You won't just get into shot, you can see where I am. Yeah, so we're there. We're actually on here, and that goes to here. So this is our resistor divider. Now, if you look at this resistor here, this is actually reading 3.5k. Okay, and if I go to the board which we've just removed the chip from, we know this one works. This is reading 3.5k. No, actually it reads differently. It's 8.3k. So that's not reading the same. So we have to see what value this resistor is supposed to be. The other thing I'm interested in, it's just going all over the place. Yeah, 6.9k. Whereas this one here definitely reads 3.5k. So this resistor appears to be in some way different on our board, the one that has the wrong voltage output. Or the one and more interesting is this one, 08A. Now this resistor, I've just looked up the code 08A, and it should be 118 ohms, 118, but it's reading 1.6. Whereas on the other board, if you just get to it, there we are, it's reading 118 ohms. The other resistor in between is actually 3.7. It's just climbed up a bit like something's charging up to about 4k. Let's have done this one. So again, I'll just find this up here. That's sort of about similar, yeah. But this resistor, I'm reading 0. something ohms. No, 2. A few ohms, yeah. Well, I should be reading 118. So let's have a look at this resistor 08A and see what value that actually is. So we can just search for SMD resistor 08A. That should do it. Okay, and we find a little chart here of them. In fact, I can see it there. 08A is 118 ohms. Okay, so it is a 118 ohm resistor, and yet one of ours is reading like about a couple of ohms, and I can't see how a resistor can possibly read lower than it should do if it's faulty. But because it's in series with these other resistors, I don't see how it can be short either. You know, it's short across it. Let's have a look at, yeah. I mean, this resistor, one end of it definitely goes to the 3 volts, and the other end of it only goes to this other resistor. Yeah, this one in the middle and this one in the middle isn't short. Okay, the one in the middle, 3.5k. So it's looking like this resistor's faulty on this one, and that would upset the voltage output. Yeah, 118, that's the good one. Yeah, this is the other one. Okay. Yeah, 3.4k, about the same. And yet 1.3 ohms. Okay, I'm going to take this resistor off and check it. And if it reads wrong, I'm going to put a 118 ohm resistor in there and see what actually happens with this. I've unsoldered the resistor. And it's fine. I thought it would be. I mean, resistors don't fail by going on low value. It's actually 118 ohms. You can see it's on the meter. So that means that here to here on this board I've got a very low resistance, 1.4 ohms. Now let's see if I can figure out where that is. I have no schematics for these. So let me just have a trace around this and figure out why that has a low resistance on it. Okay, I'll have a quick look. So just to be sure so you know why I'm coming to this decision. As this end of the resistor, I've taken the capacitor off here now. That goes to the 3.3 volts here. Yeah, sorry, the 1.2 volts here on this coil. The other end of the resistor goes to this resistor, to this chip, but this resistor itself is reading about 3.4k. So the low resistance I'm reading across here, 1.7, can't be any way related to the other side of this resistor, because I'd see the 3.4k. So this resistor, as well as going there, there's another track which goes into a via here. Now you can see where I've removed the capacitor, so if I flick it over, that's the capacitor, and this is the via. Yeah, and this via comes up here and goes around here to another point here. Yeah, and this point, if we look from where these big ones are here and coming inwards, yeah, so these big ones are actually down the edge of this thing. Yeah, so it goes under the GPU. And I can only think that that point is being monitored by something inside this, so GPU, CPU, whatever it is, yeah, APU. That is being monitored, and this again is faulty, and it has a short inside from that track that goes to this resistor, and the short is going back to this 1.2, and therefore messing up the reference voltage and giving too much voltage. So I'm going to take this one off as well and see whether or not that's actually gone away. Okay, so this one's removed as well. Let's have a look now to see if I was actually correct in my diagnosis that this short circuit across this resistor that was messing up the voltage output here was actually in the processor. So this is where the resistor was. So the capacitor's charged up somewhere. Certainly no short anymore. Let's go the other way around on it. Okay, 0.6 of a meg. Yeah, so the short's gone. So another one diagnosed. It was a processor. As to which failed first, I suspect this failed and then kind of like messed up the output from this by effectively making this almost like a short circuit here. I mean, those resistors are in the feedback network, so that's two diagnosed and two not fixed. Which brings me to these two. Now, I'm waiting for some information on this chip here. Yeah, I'm waiting for some information on this chip and this one. So let me have a look to see if I actually have anything now on the internet. Okay, yes, I do have some information thanks to a guy named Diff on Bad Caps, who told me what at least one of these chips is. And basically, it's this thing. It's a video amplifier, effectively, single, triple channel, quad, duals. But I was just single video filter amplifier. And we can see here, this is the actual chip. It has an input and an output, basically. And it's there, it's this one. So in on 3 and out on 4. And now on to that bit of knowledge, if we go back to the microscope, you can see that this connector here, this is the analog video out. Yeah, and if we go onto here, this actually goes down to this point. Yes, on the meter there, and then the other point of here, the other side, actually goes to the output of this chip, which is here. So, so this is the input. This is ground, and this is power. The other chip will be equivalent of this. Now, on these, we've actually got on the input, and I'm pretty sure this must be coming from the, effectively from the processor, yeah, in the middle, the big chip. And this one just reads open circuit. And we go to the other one. Yeah, and we can look at this one, and the input on this one reads like 3.2 meg, but they're different chips, so that may not be actually telling us anything. They're different chips, yeah. They kind of do the same job, but they're not exactly the same. This one actually has two grounds there, whereas this one has a ground. I checked on the data sheet, it has a ground and some sort of enable pin. So that's what they are. Now, the other interesting thing with this, let's just go back over to the overhead camera again. I think we can eliminate this from our point of interest, to be quite honest. So what we do know we have is a 3.3 volt, a 1.2 volt that both go into this chip, because we know from the other ones that were faulty, yeah. Now, if we look from ground on here, this is the 3.3 volt. And on this one, we're reading 28k, yeah, on 3.3. On this one, we're reading about 28k on 3.3. And the good one was reading 24, so that's basically the same. If we go again from ground on the 1.2, yeah, this one's reading 0.76, that's 747 ohms there, 0.7 of a kilo ohm, yeah. That's effectively the core, the 1.2 volts. This one's reading completely different, 380, which makes me think that one of these has got a problem with this chip, or possibly both, because on the good ones it reads 550, yeah. The other thing out of interest is this 1.8. This reads 434 ohms. This one reads 700 ohms, and a good one measures 260. Now, if we look at the two where we've removed the GPU, the processor, yeah. If we look at these, and by the way, these skills are the same as fixing graphics cards, yeah. 1.8 on this reads 265, and that's without the chip there, yeah. And on this one, again, 1.8 equals 268, similar, without the processor there. So I think from this we can assume the 1.8 is the supply for the RAM, and this is probably the RAM. So if we go from the 1.8 volts to the RAM, so on the, look at these capacitors near the RAM, and it's there, yeah, it's connected to there. It also connects to, there's some more capacitors here. I'll find the right end of them, it will actually connect to them. Just get to the right end of the capacitors. Yeah, connects to there, yeah? I'll have to answer that phone, one moment. Sorry about the interruption. Anyway, to the point. The resistance on the RAM on these two faulty ones reads different from the good one. And I'm getting the same reading as on the good ones I'm getting on the two I've removed the processor from. So it looks like those other two have good RAM, and these two may have bad RAM. So what I'm going to do now is to remove the RAM chips. Now you'll notice that this RAM goes down beneath this processor, yeah? So this will effectively go to like the memory controller inside here. So once I've removed these, I should be able to find a pin out for these and find all the data and address lines going back here. And I should be able to test them in diode mode, and if they all read the same, there's a chance these chips are okay, and taking the RAM off the other boards I've taken the processors from and putting on these may well fix the problem. If not, if I'm reading different readings on here, I can pretty much say that the the cores have got a problem. And then bear in mind that the resistance I see on the cores is different from the resistance I see on good ones. Okay, so let's get these RAM chips off and let's see where that gets us. I have a data sheet for this now, so what I'm interested in looking at is all these lines marked DQ. Yeah, 0 to 15, so 16 of them. 4, 6, 8, 4, 6, 8, so 16 altogether, yeah. And those will all be going to the actual processor, like the video RAM connection, the memory controller, if you like. So these should all read in diode mode the same as each other. If any read different, that's a very good indication that the processor core was faulty. So let's have a look to see what we've actually got on our board. Okay, I've saved some time for you guys. I've been through all of them. So they all read the same. The two boards read slightly different. So one's reading a bit lower than the other one. But the DQ lines on this all read the same as each other. And everyone read the same as each other. So it might just be worth trying, just taking the RAM off the other ones and stick them on. And personally, I don't think it'll fix it, because I'm still concerned that the actual core is reading different on these two compared to the working one. But since it's all, you know, for educational purposes only, and these same skills I say would apply to graphics card repair as well, I don't see any harm in taking the ones off the other boards, put one here, see if the RAM then reads the same as, you know, the good one on the 1.8 volts. If it does read the same, let's just try it, yeah. Okay, so I'll get the RAM chips off the other one and I'll reboard them and stick them onto this one. Ah, well, that was the plan, but these two have Samsung RAM on, which is going to read a different resistance anyway. Yeah, the Samsung's going to read different from the other two. So I don't see the point in putting them on. I suspect that these two chips here, effectively, like not a BIOS, but the flash memory, and it may well be different parameters for different type of RAM. That's the first thing. The second thing is we found really an explanation why on these two the resistance of the RAM read different from those two. Yeah. So I'm thinking now I'm really back to what I originally knew, was that the resistance on the core of these two are different from each other and different from the working one, and that I think is enough now to tell me that I'd be wasting even more time by taking the RAM off these, that I don't believe it's going to make any difference at all now. And there's actually, I'm pretty confident now we have two faulty cores again. Yeah, so not a very successful repair attempt. I think then we've gone far enough down that rabbit hole, guys. But as I say, working with this sort of stuff is a great way to practice. You know, if you've never removed RAM chips off graphics cards before and replaced them and rebuild them, then do it on things like this. Practice, yeah, because practice makes perfect at the end of the day, and these things are not really worth anything, so therefore there's nothing much to lose when you mess it up, because at first you probably will. Yeah, it takes a little bit of practice to do this sort of work. So there you go. Hope you enjoyed it anyway, even though we didn't get any of the 4 faulty ones repaired, but we've got a very good idea what's wrong with them. Yeah, so there you are. Well, you can either leave a like or a dislike for this video, however you feel about that, and hope to see you all. In fact, I will see you all very soon on another one. So adios amigos, ciao for now.